Hello, welcome to the video. In this lesson, we're going to be looking at section 1.4 and 1.5. 1.4, we are going to be solving absolute value equations. Before we get into the equations, we need to take a look at what does it mean for a expression to be an absolute value. Absolute value means that it's an indicator of a measurement and its distance away from zero. Because you're dealing with a distance, it is always going to be a positive number. So with that, there are some properties. Because it's a positive number, we know that the value of A will be greater than or equal to zero. Other things that we can take into account because it's going to be positive. So when you take it out of the absolute value expression, it gets deemed to be positive. So the second part here says negative A is equal to the absolute value of negative A is going to be equal to the absolute value of A. That makes sense because you, again, are taking them as a positive value. The products inside an absolute value will always be positive, and also the quotients will also be positive. When we look at an absolute value equation, the first thing that you have to take into account is your absolute value equation going to be equal to a positive number? So C must be greater than or equal to 0. If it is not, it is considered to be a no solution. So that's the first thing. Once you have essentially isolated that absolute value, you have to ask yourself, is that constant value on the other side positive or negative? Once you've deemed it to be positive, then you can move forward. If it's negative, it's simply just going to be no solution. If it's positive, we can now take into account that you're going to set this up as two separate equations. The first one kind of looks similar to the original equation itself. The only thing different is you get rid of the absolute value bars. And then the second one looks similar, but what's the difference is now you're going to be equal to a negative constant value. The reason for that is inside an absolute value expression, it can be both positive and negative, but once you've expressed that absolute value simplest form, it will in fact be a positive number. So for instance, if we look at example A, I have the absolute value of x minus 4 is equal to 6. Since there's nothing else on the absolute value side of the equation, it is been that absolute value expression has already been isolated. And I look over here, 6 is a positive number, so now I can move forward. So what this means is you are going to rewrite this as two separate equations. You are going to rewrite it as x minus 4 is equal to positive 6. Everything looks the same except the uh, absolute value bars are eliminated. And you are going to write this as x minus 4 is equal to negative 6. Because here, this could be 6 or this could be negative 6 as a result. So solving for the first one, I'm going to add 4 to both sides, which gives me x equals 10. I add 4 to both sides here. X is going to be equal to a negative 2. So now the question is, they want you to graph the solution. So here's kind of how you graph it. So you make a number line. And I'm going to put my negative 2 here. I'll put my positive 10 here. And I'm just going to highlight those values here. And simply, this is an indicator that if I were to go 6 away from 10, I would get 4. If I go 6 away from -2, I'd also get 4. So it's kind of like the midway point of both of those values. So that's kind of how you graph it. The second one is the absolute value of 3x plus 1 is equal to -5. Because it's already isolated and the equation is equal to a negative number, I cannot solve it. So in this particular one, it is no solution. Here in this one, I have the absolute value of 3x plus 9, and then on outside of the absolute value of -10 is equal to -4. So at this moment, our expression on the absolute value side is not quite isolated, so I got to take care of that. So that means I got to add 10 to both sides. Now I have the absolute value of 3x plus 9 is equal to 6. Now that I have the absolute value isolated and I have a positive number as its result, I can now rewrite this as two separate equations. 3x plus 9 is equal to 6, and also 3x plus 9 will now be equal to -6. So now I take each individual equation and solve for it algebraically, subtracting 9 from both sides. I get 3x is equal to -3, dividing 3 to both sides. X is now going to be equal to -1. Going to the second equation, same thing, subtracting 9 from both sides. I have 3x is equal to -15, dividing 3 both sides here. X is -5. So x is -1 and x is -5. Here's a way you can check that. So if I went over here and went with the -1, I would say -1 times it by 3 is -3, plus 9 is 6. Absolute value of 6 is 6. 6 minus 10 is -4. Checks out. Go over here with the -5. 3 times -5, -15. Plus 9 is -6. Absolute value of -6 is now +6, and 6 minus 10 is -4. So both of those values for x check out. So I have two solutions for that particular situation. Here, they're asking us, it says in a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum length of a routine is 5 minutes. They are wanting us to write an absolute value equation that represents the minimum and maximum lengths. So here, what we need to do is, since we already know the minimum and maximum lengths, we can use that to help us represent an absolute value equation. So I'm going to kind of show this in the graph on the number line. So they said the minimum value was 4 minutes, the maximum value was 5 minutes. So in order to look at it in an absolute value sense, let's look at the middle between 4 and 5. Well, the middle would be 4.5. There is just as much distance from 4.5 to 5 as there is from 4 to 4.5. It's a distance of 0.5. So using that as our representation for this equation, we can write this as, well, x is going to be equal to the amount of time you spend on your routine. So I go over here and say, okay, well, if I take the absolute value of x minus this 4.5, it will now be equal to the distance from here to here, which is 0.5. And that is why if I were to set this up as, to set up an answer for x, I can say x minus 4.5 is equal to 0.5 and x minus, whoops, minus 4.5 is equal to negative 0.5. Because if I add 4.5 here, I get x is equal to 5. I add 4.5 here, x is equal to 4. So that's where I can get those values for x and then everything in between that. Here it says solving equations with two absolute values. So if I have an absolute value on both sides of the equation, we have to solve them related to a linear equation. So it's either going to be this setup where you just eliminate both of the absolute value bars and solve for x, or it's potentially could be you leave one side of the equation the same, just remove the absolute value bars, and the other side, you remove the absolute value bars, but you multiply it by a -1. The reasoning for this is you have to check your answer to see which one holds true to the original equation. And I'll show you some examples. Looking at the very first one, it says the absolute value of 3x minus 4 is equal to the absolute value of x. So essentially what you're going to do is you could say, all right, remove the absolute value bars and solve. So this is 3x minus 4 is equal to x. If I subtract 3x to both sides, I get now -4 is equal to -2x, which means if I divided both sides by -2, x is going to be equal to +2. Let's see if that holds true. If I bring it up here, 3 times 2 is 6. 6 minus 4 is 2. So that's absolute value 2. Is that equal the absolute value 2, which is 2? Does 2 equal 2? The answer is yes, so this checks out. If we were to go to the other version, I would say this is 3x minus 4 is equal to a negative x. And if I did that, I would get -4 is equal to -4x, divide -4 to both sides, and I get x is going to be +1. So if I did that, 3 times 1 is 3, and 3 minus 4 is -1. Absolute value -1 is 1. And I have 1 here, absolute value 1 is 1. Does 1 equal 1? The answer is yes. So in this particular situation, both answers hold true, so both answers work. So x is 2 and x is 1 both hold up in the original equation. If we were to look at example B, let's give that a try. So here I'm going to write this just eliminating the absolute values. So now this is going to be 4x minus 10 is equal to 2 times by the quantity of 3x plus 1. Here, I would distribute the 2, so now this becomes 4x minus 10 is equal to 6x plus 2. I'm going to subtract the 6x to both sides, add 10 to both sides. So now I got negative 2x is equal to 12. Divide everything by negative 2. X is negative 6. So I have that one. Now what I'm going to do is, well, let's take a look at negative 6 if I plug it back into the original expression. So if I got negative 6 times it by 4, I get negative 24 minus 10, I get negative 34. Absolute value of 34 is 34. If I go over here, 3 times negative 6 is negative 18 plus 1, negative 17. But the absolute value of negative 17 is 17, and 17 times 2 is 34. So that checks out. So negative 6 is, in fact, a solution. If I go to the negative value here, it's going to be left as 4x minus 10 on the left side. But now on the right side, it's going to be 2 times it by a negative 3x plus 1. So that's where the either write as a negative or write as a negative 1, however you prefer. And now I am going to distribute this negative 1 over here. So now this turns into, actually, I'll kind of go like this, kind of bracket it a little better. So now this is 4x minus 10 is equal to 2 times it by negative 3x minus 1. Now I can distribute the 2, so now this is going to be 4x minus 10 is equal to negative 6x minus 2. Now going over here, now I'm going to add 6x to both sides and add 10 to both sides. So now I get 10x is equal to 8. Divide 10 to both sides here. X is going to be 0.8 or 4/5, however you prefer. So looking at it with this particular value, I'm going to say, okay, well, 4 times 0.8 is 3.2, minus 10 is negative 6.8, but because it's absolute value, it's going to be positive 6.8. Let's take a look here. 3 times 0.8, I get 2.4, plus 1 is 3.4. Absolute value, that's still positive 3.4. Multiply it by 2 is 6.8. So 6.8 is equal to 6.8. This is also a solution. All right, so now if I go over here, in this particular example, we have the absolute value of 2x plus 12 is equal to 4x. So now, because I only have one side of it, I just have to rewrite it as 2x plus 12 is equal to positive 4x, and 2x plus 12 is equal to negative 4x. So in this particular one, subtracting 2x from both sides, I get 12 is equal to 2x, dividing 2 to both sides, x is going to be equal to 6. On the right-hand side, subtracting 2x to both sides, I got 12 is equal to negative 6x, and dividing negative 6 to both sides, x is going to be a negative 2. Here is the problem. If I were to use this one, 2 times 6 is 12. 12 plus 12 is 24. Absolute value of 24 is 24. And then 6 times 4 is 24. 24 does equal 24. That checks out. But if I go to the other solution for x, negative 2, here's the problem. 2 times negative 2 is negative 4. Add that to 12, I get 8, and this is the absolute value of 8 is 8. But negative 2 times 4 is simply negative 8. Well, 8 does not equal negative 8. That's incorrect. So this is what is called an extraneous solution. An extraneous solution is where it's the possibility of getting extra solutions, but it gets rejected when you place it back into the original equation. So the only answer that is viable is x equals 6 in this particular situation. All right, so now we are going into section 1.5, where we're going to be rewriting equations and formulas. So essentially in this lesson, we are going to be given um, a series of equations where you may have multiple variables in the equation. They are going to ask you to rewrite them with respect to a certain variable. So for instance, here they want us to solve this particular equation for y. When they say that, that means they want you to get that variable by itself. Even though we have two variables here, x and y, we are solving for x. So at the end of it, it is going to be x equals something. So in order to solve for, not x, it's going to be y. So y is going to be equal to something. So for here, I'm going to subtract 4x to both sides. So now I'm left with 3y is equal to a negative 4x plus 9. And then finally, I'm going to divide the entire equation by 3, so then that gets me my y equals something. And in this particular instance, it's going to be a negative 4/3 x plus 9 divided by 3, which is 3. Now, similar idea, but now we are going to be solving for x. This one here is a little bit more complex because you have multiple variables of x in this particular equation. But here's what you do. Here, we are going to take x and move it into the front and kind of do almost like a reverse of the distributive property. So I'm going to put an x on the outside of this equation, and what I'm left with is 3 plus 5z. Reason why we're allowed to do that is if I were to distribute this here and here, I'd get this answer. So why is that helpful? Well, now I only have one variable for x, which is what I'm trying to solve for. So now I can divide 3 plus 5z to both sides, which now gets me x equals y all divided by 3 plus 5z. Here, they want us to use the formula of surface area of a rectangular prism, and they want us to solve it in terms of L, so the length. Same idea as the problem that we just looked at. We have two situations where we have the variable in a couple different spots. So let's take a look at this. So I got S is going to be equal to 2LW plus 2LH plus 2WH. If you notice, these two terms have L in it. So what I'm going to do first is I'm going to subtract 2WH to both sides. Reason for that is now I can do that like reverse distributive property. So now I have S minus 2WH on the left-hand side. And now I am going to take this L and now put it to the outside. And what I have left is 2W plus 2H. And now the final step is to divide 2W plus 2H to both sides, which means my L is now going to be solved for, and it's going to be S minus 2WH all divided by 2W plus 2H. Here is some common formulas that we'll probably take a look at in this section, uh, which will allow us to do some conversions. Here it's, in this particular one, it's using Celsius. It's converting Fahrenheit to Celsius. This one here is simple interest. Interest is equal to principal times rate times time. Distance, we should be pretty familiar with this one. Distance is equal to rate times time. So here, it says they want us to solve for the temperature formula for F. So looking at the formula, it is 5/9 times by the quantity of F minus 32. So want to solve for F. Here's how we go about doing it. We've got to get F by itself. So I look at this 5/9 and I want to get rid of it on this side of the equation. So in order to do that, I multiply both sides by the reciprocal, which is 9/5. So now I have 9/5 C is equal to F minus 32. From here, I simply add 32 to both sides. So now I have 9/5 C plus 32 is equal to F. So here would be the conversion to take Celsius and make it into Fahrenheit. Here it says, which has a greater temperature, Mercury or Venus? So they have two different temperatures. One's in Celsius, the other one is in Fahrenheit. So here's how I go about solving that. So since Mercury has a temperature of 427 degrees Celsius, what I would try to do is try to convert that into Fahrenheit. How could I do that? Well, you could even do the other way, however one you want to choose. If you want to use the formula, so that C is equal to 5/9 times by the quantity of F minus 32, we can go about doing that. So let's do the converting Fahrenheit to Celsius. So if I were to take 864, subtract it by 32, and then it gets multiplied by 5/9, I get a total of 462.22 degrees Celsius. So which one has a greater surface temperature? In this case, it would be Venus. Here it says that you deposit $5,000 in an account that earns simple interest. After 6 months, the account earns $162.50. What is the annual interest rate? So using the formula, principal is equal to, interest is equal to principal times rate times time, we have the interest that was accumulated, which was $162.50. So we got 162.50 is equal to the principal, which we have is 5,000. And we don't know R, and we know that the time was 6 months. And I believe it's in terms of years, so 6 months is a half a year. So we solve for R. So technically what we're going to do is we're going to divide 5,000 times 0.5, divide 5,000 times 0.5, and that is going to get our um, interest rate. So we got 162.50 divided by 2,500. That'll give us our interest rate, and we have our interest rate is 0.065, but it's written as a decimal. So if we want to convert that to a percent, it is going to be 6.5%. And that is being able to look at both solving absolute value equations and rewriting equations and formulas. Hope this helps. Till next time.